Hey guys, today I'm going to talk about the discriminant, which is part of the quadratic formula. Remember, the discriminant is the inside of the root. It's b squared minus 4 times a times c. And what the discriminant tells us is kind of what the graph looks like, and more importantly, it tells us how many real roots it has. Okay, so when you plug in b, a, and c, and you compute the discriminant, you're going to get a number, and the number is either going to be more than 0, it's going to equal 0, or it's going to be less than 0. So these are your three options, and it doesn't matter if it's, like, for example, -1 or -25. It's everything less than 0 is going to look the same, or it's going to have the same meaning. Okay, so what does it mean? Well, first thing it tells us is how many real roots it has. Okay, so remember, roots is the x-intercepts, and roots are also what we call the solutions. Okay, and the key word is real, and we saw the word real roots earlier in a problem where it said, what are the real roots? These are not going to be imaginary roots, and hopefully this video explains kind of the difference between them. Okay, so if you have a discriminant of more than 0, then you have 2 real roots. Okay, and then if it's equal to 0, you have 1 real root. And if you have less than 0 as the discriminant, then you have no real roots. Now remember, these are the solutions. So this would be like where we would write no solution. Okay. All right, so how many imaginary roots does it have? Well, there's only 2 answers. Okay, every single quadratic, remember, quadratic being x squared. Okay, we know we have 2 answers. So if we have 2 real roots, then we must only have 0 imaginary roots or non-real roots. And if we have 1, well, it's still 0 because this answer repeats. Okay, and you still have 2 answers, but since it's the same answer twice, we have no imaginary roots because this answer repeats twice. Okay, if we have 0 real roots, then we have to have 2 imaginary roots. Remember, all these have to add up to 2. Okay, all right, so what does that look like? Well, if your discriminant is more than 0, it means you might have a parabola, for example, that touches the x-axis twice. Okay. It doesn't matter if it opens up or down. It doesn't matter if it touches, both negative or both positive or splits. But if your discriminant is more than 0, then you have to touch the x-axis twice. Okay, so how do you touch the x-axis once? I mean, there's 2 sides of a parabola. Well, maybe the vertex is on the x-axis. Okay, so if your vertex is on the x-axis, you're really only going to touch it once, and you're really only going to have the same solution twice. And then you can probably guess down here what's going on if you don't touch the x-axis. You still have a parabola, you still have solutions, but now you can't see the solutions. That's why they're called imaginary. And that's not even a real good word for it. It's just kind of the word that stuck. So maybe your parabola has a vertex beneath the x-axis and it goes down. You don't touch the x-axis once. That would be what it would look like if your discriminant is less than 0. It could be up here and opens up. That has no real solutions. It doesn't touch the x-axis at all. Okay, hopefully this helps understand everything. The next part we're going to get into is what happens when you have an imaginary root, and that is when we use the letter I, and it's one of the most interesting things that we've done in mathematics in the last 300 years.